Hi, everyone, and welcome to today's OR Today webinar. We have a great presentation for you today featuring Dr. Jose Rodriguez, Assistant Professor and Deputy Director for the Adult-Gerontology Clinical Nurse Specialist Program at Uniformed Services University of the Health Sciences. Dr. Rodriguez currently serves as the Deputy Perioperative Consultant to the Army Surgeon General. OR Today would like to thank our sponsor, Ruhoff. Ruhoff is an innovator and leading manufacturer, world-renowned for offering reliable solutions and individualized service to help you meet and exceed your decontamination and materials management challenges. Ruhoff not only provides the most effective decontamination products on the market, they also allow healthcare professionals to verify effectiveness with the Ruhoff ATP Complete Contamination Monitoring System. ATP Complete is a reliable method for verifying the cleanliness of all hospital surfaces, scopes, instruments, and hand hygiene results in only 15 seconds. Ruhoff has a knowledgeable and responsive customer service department, as well as a seasoned sales team ready to help their customers find the best cleaning solution for their facilities. For more information, please visit ruhoff.com. For nearly 20 years, OR Today has provided perioperative and SPD professionals with up-to-date news and information about their profession. Our monthly magazine aims to educate readers about new guidelines, techniques, and equipment, as well as practical information about career building, problem solving, and overall well-being. To receive your free subscription, please visit ortoday.com/subscribe. Today's webinar is eligible for one continuing hour by the State of California Board of Registered Nursing. You can obtain your certificate by completing today's post-webinar survey. More details on this at the end of today's webinar. We'll wrap up today's presentation with a live Q&A. You can submit your questions anytime during the webinar by using the question feature on the webinar dashboard. We'll get through as many attendee questions as time allows. If you have questions afterwards, you can reach us at webinar@mdpublishing.com. As I mentioned earlier, our presenter today is Dr. Jose Rodriguez. Jose, you may begin whenever you are ready.
Hey, good afternoon. Thank you everyone that is joining us today. I really appreciate you guys and girls that are tuning in and allow me to share a little bit of the work that I'm really passionate about. Again, my name is Major Jose Rodriguez. I've been in the Army for about 26 years. I've been a nurse for 16 years in the Army Nurse Corps, and I'm pretty excited to be here today. Since I became an OR nurse, I think my passion for SPD and HLD came even right before I graduated from USHIS back in 2014, because I think there's a lot of work that needs to be done in order to improve cleaning and disinfection practices in the SPD or the surgical processing department. I believe there's a lot of work that needs to be done, and this is so organizations become highly reliable organizations to consistently provide quality, safe, and affordable care. I firmly believe that healthcare professionals must develop a solid relationship and collaborate closely with industry partners to evaluate and integrate the latest and most remarkable technologies that can help us improve quality and safety. So again, thank you for having me today. I would shut my camera off so I don't distract anyone, and I will give me a few minutes so I can bring my slides up and share it with you. One moment, please. All right. Before we get started, I have to go to the disclaimer. So the views expressed in this presentation are those of the authors and do not necessarily reflect or represent the official policy or position of the Uniformed Services University, the Department of Defense, or the United States government. There are no financial relationship that exists between myself and any commercial entity. The activity or the project that I will present today was considered a quality improvement project, and as such, this protocol did not require a full review from the Institutional Review Board. By the end of this presentation, I hope that you understand the negative outcomes of contaminated surgical instruments, both for patient outcomes and business outcomes. Describe the basic characteristic of 3 points of use cleaning verification systems, and determine which system best meet the criteria published by the Association for Advancement of Medical Instrumentation, commonly known as AMI. In the past few decades, advances in surgical instrument design have improved surgical outcomes that result in fewer intraoperative complications and a shorter post-operative recovery time with limited time spent in the healthcare facility than previously possible. Unfortunately, advancements in surgical instrument design pose great challenges to cleaning, disinfecting, sterilizing, and inspection because bioburden, viable or microorganisms such as bacteria, yeast, and mold is often left behind even when manufacturer's instructions for use, IFUs, are strictly followed. Biofilms, the mass of microorganisms and extracellular material that adheres to the instrument surfaces, acts as a barrier against sterilants and prevent complete sterilization of surgical instruments, thus placing patients at risk for the development of a surgical site infection, or SSI. Think kind of like your lasagna pan that you left on the counter overnight, and then you try to put that lasagna pan into a dishwasher. You probably won't be surprised that you get it out, it's not going to be anywhere clean. So when the bioburden is left inside the instrument, essentially what you see right there on that graph, in that picture, is that those bacteria begins to replicate or to multiply. And as they multiply, they make this biofilm, and they do this to protect themselves, obviously, from the external environment. And as they continue to build, eventually they burst, and they will go to a different area of the instrument, and they will start the cycle all over again. So this is why it's important that instruments are cleaned completely, because as you already know, if the instrument cannot be cleaned, it cannot be sterilized. Now, some people assume that retained bioburden is sterile if he has completed a sterilization process, but there is not evidence to support this assumption. There is at least one in vitro study that concluded that cannulated drill bits may not be sterile after the completion of a standard sterilization cycle. In this study, the researcher cultured 9 cannulated drill bits that had been inoculated with a mixture of Bacillus cereus, P. aeruginosa, and methicillin-resistant Staphylococcus aureus after standard sterilization. Of the 9 cannulated drill bits, 1 tested positive for Bacillus species that was different from the original inoculated strain. This finding clearly supports the importance of effective cleaning protocols for surgical instruments before sterilization. Now, before I continue, I want to inform you that the goal of my project in this military treatment facility, and this presentation for that matter, is not to determine or argue the effectiveness of any of these 3 technologies that I will present today. Instead, my goal was, or is, to determine which of these tools that have proven to be effective in the lab and in many other settings best meet the recommended elements published by AMI and the needs of the surgical processing department of this medical treatment facility to improve cleaning and disinfection practices. Something that I want to remind you, when these technologies are developed, they are usually tested in the lab, in a controlled environment. When you translate that evidence that is created in the lab, and you want to translate that into practice, that's when you start running into multiple factors that will affect the implementations of some of these technologies. And this is why I'm presenting to you today. In the United States, the cost of medical malpractice is estimated to be $55.6 billion, or 2.4% of the total healthcare spending. Healthcare compliance programs that ineffectively monitor internal controls of healthcare organizations are in part responsible for the 400,000 medical errors and 100,000 fatalities that occurs annually in the US. One of the causes for these fatalities is surgical site infections. SSIs occurs in 2 to 4% of all patients, about 14 million patients undergoing inpatient surgical procedures each year, and cost healthcare facilities approximately $3.3 billion annually in indirect and indirect treatment. An estimated 8,205 deaths are associated with surgical site infections each year. But what causes an SSI? Now, while there are many causes, exposing the cause an SSI, exposing a patient to a surgical dirty contaminated instrument is definitely one. The structure and complex design of surgical instruments make the manual and mechanical cleaning process difficult. The difficulty increases even more when dealing with cannulated or lumen surgical instruments that are narrow, flexible, or angled. These type of instruments are one of the most difficult type of instruments to clean and assess. Because of their complex design, they have a higher risk for retained bioburden, therefore increasing the risk for surgical site infections. Now, you take a look at that picture here on the left, you probably can figure out that is a giant cow that's been cut in half. That was a report from the NBC News that they were running, trying to show people the risk associated with surgical site infections. In this particular case, was going through the SPD and trying to explain how instruments can be in this type of conditions from a patient that received or that acquired a surgical site infection. Now, this was not the instrument that was involved for that particular patient. But here they try to show how the design of an instrument can have a negative impact or potentially have a negative impact on the patient. Now, for most of you that have seen a giant cow before, if you think about how that design, and it's a very simple instrument, but how that fat part of the instrument, which is the handle, and then you think about where the suction line is connected and where the suction tip is. Imagine cleaning that instrument, and most of you probably already done it before. When there's only one size of brush that you can pick to go through either end, and both ends are smaller than in diameter than the actual handle size. So if you introduce a brush through that instrument, you will be doing nothing to that particular area of the instrument. And if you think that the washer of the ultrasonic will take care of that, good luck. Because I just honestly can't see. Now, this is just my personal opinion. I have not done any studies on this, but the chances that the washer, the automated washer, will take care of that bioburden on that particular giant cow are really slim. Unless you connect these instruments to a specialized equipment, such as the one that are used for cannulated instruments, robotics, etc., maybe you will be able to get that bioburden out of there. But brushing is important, and clearly you are not able to reach that area of the instrument with just a simple brush. The same can be said about reamers. Reamers is another one that are very difficult. Flexible reamers are very difficult to clean because of the ridges. There's pictures on the next slide, but they're very difficult to clean. And some of the installations, some of the hospitals that are using these things, they're reusing the reamers. In the military treatment facility, most of these reamers are disposable or one-time use because how difficult they are to clean. Now, although many surgical processing departments have adopted enhanced visualization technologies such as flexible endoscopes, also known as borescope, to inspect and verify instrument cleanliness, most healthcare facilities rely on unassisted visual inspection, which is not an effective and reliable method. As a result, a more effective and reliable method is needed to verify cleaning processes and procedures. ATP, hemoglobin, and protein-based technologies are three of the most common methods that have emerged as promising solutions to verify manual and mechanical cleaning processes. In 2019, the U.S. Department of Veterans Affairs acknowledged that more than 10,000 veterans underwent endoscopic procedures that were performed with contaminated endoscopes. This does not come as a surprise, considering that there are approximately 65 steps in the cleaning and disinfection process. To make things even more complicated, human error in performing recommended reprocessing steps has been identified as the main cause of endoscopic associated infections. A few years ago, I was doing an audit, one of many audits that I do for the military in preparation to join commission. And here I'm observing this technician clean one of the endoscope or GI scopes. So as I'm observing and doing the evaluation, I noticed that person is not cleaning or addressing the biopsy port. And I waited until the third scope. When the third scope went by and she did the exact same thing, obviously missing that port, I asked her, why are you not cleaning the biopsy port? And the answer was, I didn't know I had to clean that. I was never taught that I had to clean that. Now, you might think that this is, it might sound crazy, but this is how things happen. It's just a lack of, there's knowledge gaps in training, there's improper training or or assessment to make sure people are doing the cleaning and disinfection per IFUs. And it was surprising. You can imagine the backslash of that. There was a lot of recall that had to be done. A lot of patients that received a letter that they didn't want to receive. But it is a reality. Yeah, the human error is definitely a factor that needs to be considered. In 2009, an infection control observation and a case control study regarding surgical site infections after orthopedic procedures found that 7 patients developed surgical site infections in their joint after arthroscopic surgery. The causative organism was a gram-negative bacteria that was traced back to the surgical instrument used during the procedure. In 2014, through a series of several reports, the FDA became aware of instances in which pieces of tissue have remained within certain arthroscopic shavers. I'm going to talk a little bit more about shavers later in the presentation. A device used in some, this is a device that is used in some orthopedic surgical procedures, and this was even after cleaning processes was believed to be followed according to the IFUs, or manufacturing instruction for use. The report submitted to the FDA suggested that the tissue retained on those shavers was not evident to the naked eye. As a result of these incidents, the FDA recommended surgical processing facilities to consider implementing assistive technologies such as videoscope to verify instrument cleanliness. It is imperative that clinicians and managers identify and implement solutions that can balance healthcare demands, quality, and safety. What I mean with this is that when we, managers and administrators, demand an increase in productivity and efficiency, we could compromise quality and safety if we do not invest in methods such as ATP, protein, or hemoglobin technologies to balance that demand. At this moment, there's no safety net against contaminated surgical instruments that have been through the cleaning and disinfection process. We do have a great number of diagnostic tests. We have the TOSI, known as TOSI, or the Bioburden test for the automated washers. We have the Sono test. We have the BIOS for the sterilizers. We have the Bowidic. We have many of these diagnostic tests that currently exist they are in the market, and we use it every day. But these diagnostic tests only tell you that certain parameters were met. It's not a guarantee that that instrument was properly cleaned. Only you can determine that by doing an objective assessment. So something else is needed to objectively assess the performance, not just of technicians, but also of mechanical equipment. Although healthcare personnel commonly use visual inspection to validate the cleanliness of surgical instruments, researchers have questioned its effectiveness. Protein, blood, and ATP-based cleaning verification systems have proven to be effective at detecting bioburden in surgical instruments. On ATP, for example, multiple studies have reported the versatility and effectiveness of ATP. One study that compared ATP bioluminescence, visual inspection, and aerobic colony count methods to verify the cleanliness of different hospital surfaces concluded that ATP-based technology is a sensitive and rapid tool that can be used to evaluate terminal environmental cleaning. Another study concluded that ATP-based technology offers a rapid and inexpensive alternative to detect contaminated endoscopes, and highlighted the technology's ability to identify problematic areas of complex instruments. Now, this project that I completed at this surgical center aimed to identify the most complete point-of-use cleaning verification system among 3 commercially available systems using AMI's criteria, recommended criteria. A secondary goal was to identify and address process gaps in the cleaning of surgical instruments. Because I expected to find deficiencies with cleaning processes throughout the project, I took the opportunity to address these issues as they came along. I essentially took advantage of the just-in-time information to make just-in-time decisions to improve cleaning processes in this surgical center. The Association of Perioperative Registered Nurses, ARN, and the Association of the Advancement for the Medical Instrumentation, AMI, have recommended and listed in their respective recommended practice guidelines the biomarkers of ATP, hemoglobin, and protein as options to test for bioburden in surgical instruments. Now, there are others, and I will mention what the others are, but these are the most common. ARN's position on the use of cleaning verification systems to improve instrument reprocessing is clear. Leaders must evaluate and incorporate existing technologies to objectively, remember that, objectively evaluate manual and mechanical cleaning processes. Remember, just because these technologies work in the lab, which is a controlled environment, It does not mean it will meet the needs of your organization. According to Amy, multiple studies have indicated that hemoglobin, protein, ATP, carbohydrates, and lipids are useful markers or helpful markers for bioburden detection. The ATP technology involves the swabbing of the instrument, the addition of a reagent, luciferase, luciferin, and a placement into a handheld device that measures the amount of light relative units, RLUs, that is emitted. The number of RLUs correlates to the ATP level and bioburden load. For surgical instruments, the recommended passing RLU benchmark, and this is the benchmark for the Ruhoff ATP Complete, is 99 RLUs or less. If the RLU score is above 99, the surface harbors organic matter and is considered contaminated and should be re-cleaned. Now, just for clarity, this is the tool that I use for this particular project. There are many others ATP systems out there, but this is the one that I use for this particular project, so you can relate. The protein-based systems, which is a Hallmark product, just like also the hemoglobin is a Hallmark product, measures for residual protein on surfaces, which is a significant component of bioburden. The presence of protein in surgical instruments indicates an unclean surface and a potential source of cross-contamination. Protein testing is accomplished by moistening the tip of a cotton swab with sterile water, swabbing the surface of the item being tested, placing the swab in the vial, and shaking it vigorously. If the liquid or any part of the swab turns blue-green, the surface harbor protein and is considered contaminated and should be cleaned, re-cleaned. Lastly, the hemoglobin-based system is an all-in-one test that indicates blood residues. The presence of blood in a surgical instrument indicates an inadequately reprocessed instrument and a source of cross-contamination. Hemoglobin testing is similar to protein testing. If any area of the swab turns green or blue, the surface of the instrument harbor blood residues and should be re-cleaned. To help clinicians and managers make an informed decision on which technology to adopt, Amy has published a criteria that describe the elements that cleaning verification systems should have. As previously mentioned, several test methods are commercially available for the rapid detection of organic residues left from surgical instruments. Ideally, and according to Amy's, a point of use verification system should have these 9 elements. It should be rapid. This means that the system can provide just-in-time results so the end user can make just-in-time decisions. It should be easy to perform or simple to use. It should be sensitive and accurate, which means that the system must be able to meet realistic benchmarks and be able to provide contamination levels values that are close to its true value. Repeatable, which means that different users performing the test using the same methods and equipment under similar conditions should obtain similar results. Free of interfering substances. This means that the testing device does not include any substances that may pose a risk to a patient if it is left on the instrument after testing. It should be robust, meaning the system does not require exacting conditions or time constraints that cannot be achieved in routine reprocessing areas. Also, cleaning verification system should allow for quick testing right after cleaning and in a way that it will not damage or require re-cleaning of the device. Lastly, and although not officially part of the AMIS criteria, the tool should be objective and affordable. Now to the important part of the project. To evaluate the 3 cleaning verification systems, I collected data from a convenient sample of 150 surgical instruments used in the main operating room. More specifically, instruments included in the project were those with a lumen greater than 1 millimeter in diameter. This has to do due to the limitations on the swab that is available that is a smaller swab that is available to collect the sample. Now, there was a special focus on instruments that were not able to sustain mechanical cleaning. You can imagine why that is, but I will talk a little bit more about that later in the presentation. I utilized the benchmark recommended by the manufacturers, IFUs, to protect the integrity of the testing procedures. I performed all the 150 tests. All the tests, which were broken down in 50 per system, were completed after manual decontamination. All instruments were considered clean through visual inspection before testing. So again, the convenient sample included 150 cannulated instruments divided equally among the 3 point of use cleaning verification systems arriving from the main operating room. When testing these instruments, the author adhere to the manufacturer's instruction for use to ensure accuracy and prevent false positive results attributable to cross-contamination. The author gathered and recorded data from each performed test, which resulted in a standardized sampling process. It also protected the integrity of the testing and data collection process. The author used a nut and bolt gauge to measure the diameter of each cannulated instrument to verify that the instrument met the inclusion criteria and to select the corresponding testing swab before testing. In addition to test scores, data gathered included test results, whether it was pass or fail. If it was an RLU, then I will annotate the number reflected on the screen of the handheld device, nomenclature, surgical specialty, a diameter for each instrument, and the time required to conduct each test. I'll talk more about that timing later in the next slide. So what did I find? Rapid, cost-effective, and simple are the essential qualities that gave ATP the advantage over protein and hemoglobin. ATP achieves the fastest processing test time at 66 seconds, the lowest cost at $2.47 per test, and was the only system that met the objectivity criteria recommended by herein and AMI. Furthermore, the ATP and hemoglobin system were more robust than the protein-based system on two merits. First, both systems demonstrated the ability to operate without interfering with workflow due to their simplicity to test and their capability to provide rapid results. Secondly, none of the disinfection solutions used during the manual decontamination of power instruments appear to interfere with ATP or hemoglobin testing. The literature supports that the protein system is the most sensitive due to its broad spectrum. Although all systems achieve an accuracy rate of 96% or above, we must consider that protein and hemoglobin are analog systems that may lead to different interpretations while analyzing the results. This is because analog systems such as protein and hemoglobin rely on the visual method through the utilization of a color chart to interpret the test results, which can vary from person to person. Overall, ATP-based technology best met AMI's criteria, the needs of this surgical center, surgical processing department. All systems were found to be safe, repeatable, and simple to perform. Now, to expand a little bit on this, when I talk rapid, how rapid the testing was, I want to point out that ATP takes the actual analysis of the test take 15 seconds. Now, the way that I measure the timing of testing was from the time I selected the instrument to the time I recorded the results. So that includes picking the instrument, measuring with the gauge, selecting the brush, setting up the kit for testing, placing it on the unit, and then allowing the unit to do the analysis and then record. In the case of ATP, I didn't have to record them on paper because the unit provides for electronic storage of those results, so I didn't have to go to that step. So that's how the ATP of time measuring went. It only take 15 seconds to get the results, but the whole process took 66 seconds. I did the exact same thing with hemoglobin and protein. Now, hemoglobin, it will give you hemoglobin. If there's a blood residue on the instrument, it will give you an immediate result. You don't have to wait 15 seconds or 5 seconds. It's an immediate turn. And so the total for that, the only reason why they achieve a higher score than ATP was because you have to take the vial. The kit comes in 2 vials, so you have to put the content of one vial into another vial, and the manipulation of these small parts takes time. You have to have a testing station essentially to put these things. And now I'm talking more about complexity and how easy it is to test, but there's some of the reasons why it took longer to conduct some of these tests. Protein, very similar. Now, protein is very similar to hemoglobin aside that it takes 5 minutes in the IFU, and this is all come from the IFUs in terms of how long they tell you to wait for the actual testing results. And the protein IFU tells you that you have to wait 5 minutes minimum for that final result. So it would not take that long. I will assume that it will take me similar to what hemoglobin, because it's a very similar kit. But because I had to wait that 5 minutes, that automatically came the standard for the protein. All right, let me go to the next slide here. For EC and complex, you can see that how many steps it takes you to do a test. They're pretty close. Overall, they're very simple to use. If this it's not really any of the system. They're not complicated at all. It's just that some of them require a different setup. Like I mentioned, if you were to use the ATP one, you would have it comes with a carrier that you can have on your shoulder, and then you can walk around with them. And the manipulation of the swab, it is very similar to if you ever done a wound culture. It looks exactly like a wound culture kit. So you just open it up, swab the instrument, put it in, and then you run the test. You don't have to have an actual surface unless you are either have a large instrument, or you maybe when you're doing one of the cannulated ones that are long that you require the long brush, then maybe you need a surface. For the most part, you can actually walk around with this. It's very mobile, very compact, and you actually can swab, and you don't have to analyze right away. You can just swab the instrument and put them in the pouch, and then later you can sit down and pop the ampule, and then you can run the test separately. You don't have to do it right at that moment if you're busy. Now with hemoglobin and protein, like I mentioned, because they're really small vials, you have to actually about the size of the actual picture on your screen, maybe, depending how big your monitor is. But they're very small, and they come with a stand where you can put the ampules in while you do the testing and put the cotton swabs in and cut them and all that stuff. And that way you can just leave in there. In the case of protein, then you have to wait the 5 minutes. You can label the time that you put it in, so you know exactly when. I did measure all this time with a digital timer, so I knew when to go back and check to see if it turned. Now I did have maybe one or two. It was two. It was two of them that at the 3:30 mark they turned positive. All the other ones they turn almost immediately. When it comes to sensitivity, this is something I did not measure, obviously, in the project. It's something that is done in the lab. This information comes out of the IFUs. So there you have it. Feel free to read on this. They all have white papers, and they also explain you how the technology works. So I did not mention this, measure this during my project. In terms of accuracy, when I say accuracy, it's meaning how many of the tests were valid or invalid. All the tests that I did from ATP, there was no reason for me to discard any of the results. For the most part, they're all within the parameters. They're very similar to each other. When something was contaminated, I have very similar numbers than when they were, obviously they were not. But for hemoglobin, there's one test that had to be discarded because I couldn't really figure out whether that it was actually turning the color that they want. I think in this one is a dark blue, dark blue, green, and it was kind of turning, but wasn't really enough for me to say yes, I'm absolutely positive that is a bioburden positive. Now we treat it as such because when in doubt, then you decide on the worst case scenario. But it wasn't a yes, absolutely true. It is positive, like some of the other ones that we received. In the case of protein, there's two tests that were discarded because there was a solution that this particular SVD was using after manual cleaning on power equipment. I will talk about that later, but that solution was making the test to give you a false positive. So I discarded those two tests once I figured out that was the cause of it. And the only reason why I figured it out was because I kept recleaning the instrument and I keep testing it, and we were not able to pass that particular instrument. Actually, it was a shaver, and until we figured out that they were spraying it with a solution that was reacting to the protein test. And I didn't find this until the end. Protein was the last system that I tested. I started with ATP, then I did hemoglobin, then I did protein. And the reason why I didn't find ELI was because the other two never reacted to that particular solution. It was protein, and it is mentioned on the IFUs. If you want to know more about it, I'll talk to you more later in this slide. Repeatable. This is, again, I didn't measure this. This is something that is done in the lab when the product is developed. They all have, this is what essentially support each technology. So if you want to know more about it, just feel free to go into this on the website for these particular products and read more on the technology and how the technology support bioburden testing. There was no risk to a patient at all because the only solution that become in contact with the instrument is sterile water. Most of these cotton swabs become already pre-moist, so you don't have to do that. If you're testing in the decon area, then you don't have to worry because those instruments are already wet. But if you're in the prep and pack and you're doing testing there, and you're using the long swabs or the cannulated swabs that are dry, then you might need to moisten them a little bit so it can help you collect, better collect a Bioburden if there's anything in there. It will assist you during the sample collection. Immediate testing, all of them allow for immediate testing. Aside from the one that I mentioned for the solution that was being used after the manual cleaning of the power equipment, they were sprayed with this alkaline solution, or alkaline solution that was reacting to the protein. So in this particular, for this particular facility, if they would implement protein, for example, they would have to make an adjustment in the workflow process to either eliminate that solution or to test right in between the manual cleaning or and the spraying of the power equipment. None of these kits that will damage your equipment. Again, the only thing that become in contact with the instrument is just sterile water, so there's no need to re-clean or any damage that might cause the instrument in the long term. Finally, robust. When we talk about robust, which one was the most robust? I decided that based on the data that I collected, that ATP was the most robust, not only because they did not react to that particular solution or any solutions that were being used that were used at that particular surgical center, because they were the most mobile. You can the challenges that I encountered while implementing or testing this tool in the SPD were minimal compared to the other two systems. So it was not just about the solution that reacted or they didn't react to any solution, but they as a whole how the technology performed in the SPD while I was conducting testing, specifically when it came to workflow. And we will talk more about, I think I talk about a little bit about the timing, but when we talk about workflow, all these technologies are created and they work perfectly when they are developed. And to their point, all three do their job. They all detect the Bioburden and they all detect what they said they're supposed to detect within their spectrums. When you translate this, when you bring these tools to the SPD, then you start thinking about, okay, is it really feasible for me to implement this or to integrate this to the workflow? Remember, you're not doing this right now. If you're not, but if you bring this either of these three systems, you will have to figure out how much more time will this cost to an employee to stop what they're doing and do the testing and then continue on. Now, you ask me, 5 minutes in the decon area, it's a long time. It might not be long in the prep and pack because it takes you a little bit longer to inspect the instruments, to assemble, so you have a little more time to wait. But in the decon, 5 minutes is a long time. So, and I experienced that I didn't experience with hemoglobin, obviously, because I didn't have to wait. It was an immediate result. ATP, 15 seconds, that's doable. Now, stopping a tray to go from the manual cleaning to the ultrasonic or the washer, 5 minutes, that's a long time. And at time, I have to just let the tray go and test it again after the set went through the ultrasonic cycle, just to make sure that the instrument was properly cleaned before I allow it to go through the automated washer and eventually to the prep and pack. All right. So this project also evaluated an additional two elements, the cost and performance. Now, I want to mention that this is the pricing that I'm showing here is government pricing. So you will have to reach out to the particular manufacturers to find out what is the right pricing for your area, for your market. As previously mentioned, ATP has the lowest price per test among all three systems. However, an initial investment of approximately $2,200 is required to acquire the test unit, the software, and the calibration kit. While the costs related to these items have been reported by the literature as a drawback, these items make the tool digital and objective, which is the most significant feature of the tool. Now, when it comes to hemoglobin and protein, they do not require an upfront investment, obviously, because they don't have any technology involved. However, both systems are analog and subjective. Furthermore, the cost per test for cannulated and non-cannulated instruments are significantly higher than ATP, which make them more expensive over time. If you were to try to calculate how long it takes you to make the money back, let's say you decide to go with the ATP technology, and this is based on the pricing for the Ruhoff ATP Complete, you would have to conduct 600 tests of hemoglobin testing of this particular product to make the money back, that initial investment, or you would have had to do 900 protein tests to recoup that money back. I will probably guesstimate that will take you maybe about 10 months, depending on how much testing you do or how much testing you need to make the money back. So it is instead of the front cost, it's not really an issue. This is, for the amount of money we spend in the operating room and the amount of money that some of the equipment that we use costs, $2,200. That's cheap change for us, at least from the surgical services standpoint. So I also want to mention that the pricing that I reported there initially was the non-cannulated equipment. For cannulated equipment, you're going to need an additional brush if it's too long, or the diameter is so small that the standard swab cannot go through it. Then that's an additional brush that you have to use, which and that will incur in an additional cost. So that's why you have the two different pricing there for cannulated and non-cannulated. But I will say that having a objective tool that can give you a black and white, a number that employees or staff members can follow, it is definitely important and helpful because you don't have to worry about, is it really green? Is it really blue? It's really black and white. And I know I'm talking about maybe seconds here, maybe seconds, maybe a minute. Try to debate whether this was clean or not, but a minute, it'll add up. And when you're doing hundreds of tests every month, it can become a challenge. Not only that, but then when you have something that is really objective and you can say, look, if it's 99 or above, if it's 100 or above, it's 30, have to be re-cleaned. If it's below 99, it's good to go. It's very easy to make that decision. So I want you to consider that. All right. Performance was the second element I evaluated. The point I want to get across here is that all systems were able to detect bioburden effectively. It is essential to mention that correction to cleaning processes and procedures were made during the testing phase. I mentioned that earlier. This could explain the low detection rate by the protein system, as it was the last system to be evaluated. All 3 point-of-use cleaning verification systems effectively detected 8 of 150 inadequately clean instruments. ATP detected 3 out of 50, hemoglobin detected 4 out of 50, and protein 1 out of 50. The contamination rate for non-power equipment was 3.6%, 3 out of 84, and 76.6%, 5 out of 66 for power equipment. 1 of the 50 hemoglobin tests were ruled inconclusive, as I mentioned before, and 2 of the 50 protein tests were ruled invalid. Now, the contamination rate for power instrument 5 of 66, as I already mentioned, was a top concern because this type of instrument cannot sustain mechanical cleaning and are packaged for sterilization right after manual cleaning. A recent quality improvement project performed by myself, last year I did this at a large medical center, documented the importance of mechanical cleaning and how it can significantly lower the chances of bioburden retention. In this project, the one that I did last year, a total of 14 out of 59 of manually clean instruments tested for ATP failed. The failure rate after mechanical cleaning was significantly lower when compared to manual cleaning. Only 2 out of 59 instruments failed ATP testing after mechanical cleaning. If you want to read more about this particular project that I did last year at this medical center, you can find it in PubMed by scanning that QR code. It was published in ARN. It's a very interesting article. On that one, I just used the only tool that I used was the ATP, the WhoHelp ATP tool. I did not use the other ones because here we were trying to find something for them, and they were already leading to that direction. And that was actually happened to be my project for my doctorate. So it was a perfect scenario for me to go ahead and help them implement this tool and to test it. Now for this project, the one I'm talking to you about today, one instrument, an orthopedic ionic shaver, achieved the highest positive rate, accounting for 50%, 4 out of the 8 instruments of the detected contaminated instruments. Cleaning issues with these type of instruments are not new, as previously mentioned. The author, in collaboration with the SPD supervisor, investigated the causes of the positive trends of the ionic shavers. A lack of compliance with IFUs, knowledge gaps, and a lack of proper cleaning equipment were identified. As a result of these findings, 3 important actions were taken by the leadership. 1, targeted training on how to clean the ionic shaver per IFUs was completed. 2, cleaning brushes specifically designed to clean these type of shavers were acquired And 3, random performance assessments were conducted to ensure compliance. Following the leadership actions, there was a significant improvement in compliance and performance. I want to pause here because if anything, I want you to remember in this presentation is that it is great that you implement one of these 3 systems if you don't have any. And it is great that you are cutting dirty instruments. However, I don't want you to stop there, because if you stop there, all you're doing is just sending the instrument back for recleaning, but you're not fixing the issue. You're just fixing the symptoms. And what I need you to do once you start collecting this data is to go back and act on that data. And that's exactly what we did at this last year at that medical center and during this project. We took advantage of the just-in-time data and we started making corrections right away. That way, you just attacking the problem right at the root. And in this case, we have some technicians that were very junior and they didn't understand that the importance of performing cleaning in a certain way, right? As recommended by the recommended practice guidelines such as AMI and herein, or following the IFUs that came with the instrument, in this case, the shaver. I found out that there was issues with the system. They were not using the right brushes. If you don't know about the Smith & Nephew shaver, they have 3 different brushes. You require 3 different brushes to clean this piece of equipment. They didn't have any of them. They were trying to clean it with a standard brush that did not do the job. And this instrument is very, it has a very crazy design, especially the connection where you put the shaver tip. That attachment there is very hard to clean at that bottom if you don't have a brush that is similar to, they call it a broom brush. It looks like a mini broom. To clean the bottom part of that shaver, you won't be able to get that Bioburden out of there. And also, we were able to then use the tool to conduct performance into that particular employee, right? It was not punitive, but we're trying to make sure that once she received the training, that she was conducting the cleaning steps for manufacturing instruction for use. So that's what I want you to make sure that when you use these technologies, that you use it in a way that is effective, because otherwise they're not going to help you solve the problem. Now, there is a methodology to implement these technologies, and you need help with this. I don't have time, obviously, to discuss all that, but send me an email and I'll point out the right direction. But there's a methodology to implement this system so they are effective. Throughout the 3 rounds of testing, all systems yielded false negative results, even when there was observable content on the sample swab. ATP have 11 out of 50, hemoglobin 16 out of 50, and protein 7 out of 50. These findings are significant and concerning because they show the limitations of each system and not capturing every form of bioburden. Educating the staff on how to react to false positive results is crucial to ensure surgical instruments are entirely clean prior to packaging and sterilization. Now, this was not a surprise. This is essentially this is nothing that the manufacturer is not already telling you. In the case of ATP, if you are testing an instrument that has been improperly cleaned and have been through multiple sterilization cycles, you cannot expect to detect anything living in that instrument. What you are trying to, once you swab that instrument, if you get something back, you're going to be trying to test for inorganic material, which in the case of ATP is not going to work because you need ATP, and that's energy coming from some sort of living cell. The same could happen to protein if the protein has denatured to the point that it's not detectable anymore. So all the systems have their limitations. What I want you to do here is you want to make sure that the staff and the employees knows that when that happens, that they cannot take that false positive as a true positive, as a false negative, sorry, and then push the instrument to be packed. And if you swab that instrument and in whatever system, any of the system give you a negative read, but you see a visible content on that cotton swab, send that instrument back and get it recleaned. You don't know what that is in there. Or if you have any other system available, test it with that system. Otherwise, send it back, get as much as you can out of there. It could be rust, it could be the instrument decaying, but you don't know that at that point. So you need to make sure that the instrument is as clean as possible before you push that to the prep and pack. Now, all 3 systems demonstrated their ability to detect bioburden in surgical instruments not detected through visual inspection. However, it is essential to remember that these systems all have limitations that must be considered before investing and integrating them into the SPD workflow. These systems are supported by specific markers that limit the spectrum of organisms they may detect. Minimizing workflow disruption in the SPD is crucial as thousands of instruments are processed daily. Introducing a cleaning verification system that has a minimal impact on workflow is vital to ensure the initiative is feasible and sustainable. The impact this project had in this military treatment facility was significant. It yielded immediate changes and improvements in the SPD operating procedures, education, and mentorship to close knowledge gaps and increase capabilities. Just-in-time feedback provided by the 3 cleaning verification system was valuable. It supported the corrective actions taken during testing without causing delays in reprocessing or disruptions in the workflow. Results suggest that ATP bioluminescent technology is the most rapid and cost-effective method to assess performance and cleanness of surgical instruments at this military treatment facility when compared to hemoglobin and protein. Yet, it does have limitations that must be addressed and mitigated. Perhaps a combination of different systems may be necessary until further research is completed to determine the best solution. Now, I want to say here that there's a reason why AMI and ARN has not said this is what we want you to use, right? They give you the 5 markers, 6 biomarkers that they tell they're good at detecting bioburden, but they're not going to tell you yet this is what you should be using because there's not enough evidence out there. Now, I will say this much: they are stating that whatever solution you decide to go with must be objective. Okay, I just presented you 3 tools today. Now you make that decision. That's as far as I'm going to go without endorsing any company in particular. But in my experience, objectivity always will prevail over subjectivity. ATP hemoglobin and protein technologies are viable and affordable solutions to increase bioburden detection and support improvements in cleaning practices and patient outcomes by decreasing the risk of acquiring an SSI. Anything is better than nothing. So if you don't have anything right now, any of the system will do for you. I can guarantee you that. Future studies should focus on identifying standardized benchmarks currently recommended by multiple manufacturers. This is in the case of ATP, to decrease tool variability and increase sensitivity. Finally, AMI's criteria needs to improve as it lacks objectivity. For example, the elements of RAPID states that a system should provide just-in-time results so the end user can make just-in-time decisions. What exactly does that mean? Does it mean 1 minute, 2 minutes? The same can be said about how easy or complex a system should be. Improving the criteria could provide better guidance to clinicians to evaluate cleaning verification systems more accurately and effectively. Now, where next? Well, we're hoping that the standardization of some of these in terms of the benchmarks, like I mentioned, right now, when you look at technologies such as ATP, there are different manufacturers that have different benchmarks. So I think that's something that needs to be looked at. I know that 3M, as far as I know, last time I checked, they don't have a benchmark. They allow the institution to develop their own benchmarks. I mentioned the one for Ruhoff. There are other manufacturers that have other benchmarks based on the literature. There needs to be a research done to say this is the parameter that we should be looking at, or maybe compile those research that have been done by these different manufacturers to determine which one was the best research and then adopt that standard. So then you can use those numbers and compare across multiple facilities. Right now, a problem that we have in the military is that we have so many institutions using different ones. Some of them have 3M, some of them have the Ruhoff, some of them have other ones like the one produced by Healthmark, that it makes it difficult for us to compare and analyze the results that they are providing. When it comes to application to other clinical areas, all I want to say here is that in this technology, some of them can be applied in other areas. Again, ATP can be taken to the environmental side of the house. You can take it to the operating room. I did that when I was at Fort Bragg at Womack Army Medical Center. We used it to evaluate the effectiveness of cleanliness for the environmental team. And into other areas of the hospital. So this is not specifically designed just for SPD. There are benchmarks that are being published, and Ruhoff has benchmark for those non-critical areas that you can actually take this tool and use it to improve cleaning in other areas of the hospital. And then finally, is taking these 3 and doing more projects like this and publishing these results so people can be more informed before making a decision. Now, in summary, visual inspection alone is not enough to effectively assess the cleanliness of surgical instrument. Rather than relying on subjective visual inspection, the 3 technologies presented quantitatively and qualitatively assay for ATP, hemoglobin, or protein, which are all bioburden components. The result of this project suggests that ATP best met Amy's recommendations and the need for this military medical center. All three systems were considered to be safe, sensitive, repeatable, and simple to perform. The ATP testing process proved to be more rapid and robust than hemoglobin and protein, and are less likely to impact the organization's workflow. The rapid availability of results permitted just-in-time adjustments in cleaning processes and performance, and the opportunity to correlate results with individual knowledge gaps or equipment and supply deficiencies. ATP accuracy demonstrated to be superior to hemoglobin and protein due to its capability to provide quantifiable and objective data. The system ability to test non-critical surfaces in addition to surgical instruments shows the system versatility and its potential to impact clinical areas outside the SPD. The digital aspect of the tool decreased data entry errors and assist the user with data mining and analysis. Finally, ATP was found to be more cost-effective than hemoglobin and protein. The improvements made in cleaning processes during the duration of this project demonstrated the positive impact that point-of-use cleaning verification system can have in surgical instrument processing. Well, that went pretty fast on my end. Probably felt like forever for you, but I want to thank you for your attention, and probably have some time for a Q&A session. So if you have further questions or additional information, or we can answer your questions while we are here today, please feel free to reach out to me. If you have questions about the particular, about the ATP tool that I use for this project, reach out to Ruhoff. Or if you have questions about the other products, just give me a call, an email, and I'll point you in the right direction. Thank you for your attention. It's been a pleasure, and we will take questions right now.
Thank you so much, Jose, for a great presentation. We do have a few questions that have come in, and as Jose mentioned, if you have questions after the presentation, you can submit those at webinar@mdpublishing.com. So let's try to squeeze in one before we have run out of time. And that one is first a comment of, first, let me thank you for your 26 years of service. And then the question is, with the ATP swabs, how do you account for lumens that are larger or smaller than the swab tip and can't control with the walls of the lumen?
That's a great question. Now, I can tell you that for the ones that are large, usually you don't have much of an issue if it's short enough for you to manipulate that swab. I found that the one that the Ruhoff made, the design is it's good for you to manipulate so it won't break, and you can go back and forth with it, and you can follow the best advice I can give you is always follow manufacturing instruction for use. But I can tell you that the challenge will come when you're trying to test cannulas that are less than 1 millimeter, and I believe there is a 0.5 millimeter brush. I'm not sure. But anything smaller would be really hard because you can't fit through the cannula. Now, I didn't find any in the surgical processing, and I did it at both at a large medical center and at a surgical center, and I didn't find an instrument that I was not able to swab. The largest cannula that I tested was about 60 millimeters, and that was from a drill gun. Those are very big, and for those, I didn't have any issues using the standard swab that comes with the 3 kits, so that was pretty easy. I found out that the other kits, if you're not careful enough, they'll break inside, so you got to be careful. If you twist too much or bend too much, they might break. So make sure that when you select the brush, it's the right size. Otherwise, you might leave that piece, that tip inside the brush. But that is a great question.
All right, so we are out of time, but thank you so much, Jose, for this fantastic presentation. I would like to encourage everyone to visit today's sponsor to learn more about the products and services that they provide to our industry. Please visit ruhoff.com. A quick reminder that you can obtain your certificate by completing today's post-webinar survey. The survey will be emailed to you 1 hour after the completion of today's webinar. You must complete the survey to receive your 1 continuing education hour, and you'll be able to download the certificate once your survey is submitted. If you have any questions, please contact us at webinar@mdpublishing.com. We'll be back next month with another OR Today webinar. Please visit ortodaywebinars.live for more details and complimentary registration. Thank you all and have a fantastic day.